Alright, so the following graph, this is part 2. The following graph of a normal distribution has a mean of 12 and a standard deviation of 3. So we can see the middle value right here is 12. So that's my mean. My mean is 12, and my standard deviation, which is sigma, is equal to 3. So it goes out in 3 in each direction. 12, 15, 18, 12, 9, 6. Before I start answering any of these questions, I'm going to fill in my information on my graph based on the 68, the 95, and the 99.7 rule. And that rule states that within one standard deviation, 68% of my data is accounted for. So because I have two sections, I have to take 68 and divide it by 2. So 34% is here, and 34% is there. Next, I know, and this is in your book too, between 3 standard deviations, I know that 95 is accounted for, but I already have 68 in the center. So what I have to do is I have to take 95, subtract off my 68, which leaves me with 27, and then divided by 2, because I have 2 spots there, is 13.5. So that means that each one of these is going to be 13.5%. 13.5%. And lastly, I have my 99.7, but I have to subtract off the 95% because I know that's what's left. So I have, between those 2 points, between the 3 and all the way to the 21, and then again, because I have 2 spots, I'm going to have to divide that one by 2 as well. So I have 99.7, get rid of the 95 that's in the middle, and then divided by 2, I'm left with 2.35. And that's 2.35 on that side, and 2.35 on that side as well. So now it's a lot easier to actually fill in my questions, right? First question says, what percent of the data is greater than 12? Well, I have 34%, 13.5%, and 2.35%. But what happens when I add all these together? What am I left with? Well, the 99.7 is everything, right? So what am I left with? If I have 100% total, subtract off the 99.7, that means I'm left with 0.3%. 0.3% off each edge. So that means that I'm going to have, divide that by 2, is going to be 0.15. So the rest of it that's going on this side is 0.15, and on that side is 0.15. So that means greater than 12 is anything from here on. Anything from there on. So I could take the 34, add my 13.5, add my 2.35, and then finally add my 0.15. Should leave me with 50%, right? We've worked it out on calculator and it looks right on the graph. So it should be 50% of my data is contained above 12 and also would be contained below 12. Next thing it says, what percent of the data is greater than 6? Where is 6? Okay, 6 is down here. I've got all my information filled in and it wants greater than. So again, look at 6 and go to the right. So you can take the calculator and you can add all the values that are greater than 6. 13.5 plus 34. You might know right away what it's going to be anyways. Plus 34 plus 13.5 plus 2.35 plus 0.15. Should be 97.5% of my data. 97.5%. Okay. Next one, what percent of the data is greater than 18? Here's 18. We're not looking at the 6 anymore. If I go from 18 on, I just have the 2. I have the 2.35 plus the 0.15. So I get 2.5. 2.5% of the data is greater than 18. Next question, what percent of the data is less than 15? Here's 15 up here, less than, so I'm going back that way. So I'm going to add all the values that are less than 15. So I have a 34 plus a 34 plus a 13.5, my 2.35, and my 0.15. I get 84%. Oops, I missed one there. I forgot to write it down. 84%. Less than 9 is right here. And again, I just add up the values. I might have done this one, I don't know. 13.5 plus 2.35 plus 0.15. That's equal to 16%. Okay, so that's question 1. Basically, fill in the values on your graph first. If you can remember this and write it down, it's in your book as well. That's how you answer through all those questions. All right, question 2. Determine the standard deviation for the following graph of a normal distribution. First thing I did was I looked at from 4.575 all the way up to 5.075 is a distance of 0.5. So half that distance is going to be a distance of 0.25. Okay, because I just take half of 0.5. So the middle line is going to be 0.25 up from 4.575. So 4.575 plus 0.25 is at 4.825. 4.825. We're just looking for the standard deviation, right? Standard deviation is how far it goes 1 in each direction. This number 95% tells me that that's been two jumps, right? I want just one jump, so I want to see how long it's going to take to get to the green line, right? Because that would be one jump. So if that was 0.25, right? Because you get 0.5 divided by 2, and then divided by 2 again is going to get you 0.125. So that means the green line is going to be 0.125 more than 0.4575 or 0.125 less than 5 or 4.825. So 0.125 is what it's jumping to get down, and that's for one jump, and that would be my standard deviation. So my standard deviation is equal to 0.125. All right, next question. The mean and standard deviation of a set of heights are mu is 100 and sigma is 25 centimeters. It says sketch a normal curve to show the distribution of heights. Mark the points 1, 2, and 3 for the mean. Okay, so the first thing we need to do is we need to draw, let's draw this below. Whoops. So there's my graph line along the bottom. We use red, it goes up and then down, and that should actually be straight. Okay, so there's my graph. It's got a mean of 100, standard deviation of 25, and it wants me to mark off 1, 2, and 3. So one step this way would be 125, 2 steps would be 150, and 3 steps would be 175. Back in the other direction, you'd have 75, 50, and finally 25. Okay. Now again, before we answer any of the data, we can do the same thing that we did above for this question 1, where we had 34, 34, 13 and a half, 13 and a half, 2.35, and so on. Right? Because we know that's the amount of data that's going to be in there. And it's the same thing. So we have 34, we have 13 and a half, we have 2.35, and then lastly off the ends we had 0.15. Now it's really easy to answer all these questions. Whoops, that should be a 34. All right, between which 2 points does 95% of the data lie? Well, we know that 95% of the data lies between 2 standard deviations, right? So 95% is going to be between, here and here. That would be 95%, right? Between 2 standard deviations of the mean. So that is between 50 and 150. Those are the 2 points. Between which 2 points 99.7 of the data? Well, we know that 99.7 is between 3, right? So it's going to be between there and there. So that's going to be between 25 and 125, right? 99.7% of the data. Next thing it says, between which two of these points to the right of the mean? So to the right of the mean, we're looking in this section here, to the right, does 13.5% of the data lie? Okay, well we know that 13.5% lies between these 2 points right here, right? Because there's your 13.5. So between 125 and 150. Next question, between which 2 of these points does 81.5% of the data lie? Okay, well we don't have 81.5%, but we can try to figure this out based on, well, if I add these together, say I add 34 plus 34, I get 68. What if I add on the 13.5? Oh, 81.5. Okay, good. So that means between, if I add the 34, and the 13.5, I'm going to be right here all the way to here. It says there are 2 possible answers because you could go to the right or you could go to the left. So it could be between 75 and 150, or if you included this 34 and went this way to the 13.5, you'd be between 50 and 125. Okay, so again, just basically cutting the graph into sections, knowing how much each section is worth. All right, question 4. A shipment of eggs has a normal distribution with a mean height, so that's your mu. Mu is equal to 5.2. Standard deviation, which is your sigma, is equal to 0.12. It says sketch a normal curve to show the distribution of heights, mark off the data, right? So we have the bottom of the curve, we have the curve there. I know that the mean is 5.2, and it wants us to mark off 1, 2, and 3. Same kind of stuff as before. So 1, 2, 3, 1, 2, 3. Okay. Standard deviation is 0.12. So that means from 5.2, I'm going to go up 0.12. So 5.2 plus 0.12 is 5.32. Then we're going to get 5.44. Then we're going to get 5.56. Going the other way, I get 5.08. Then I get 4.96. Then I get 4.84. All right, and then we have all these questions based on our information above. And again, you can fill in all your data, right? We know that 34% is there. Whoops. We know that 13.5 is there and there. And then we know that 2.35, 2.35, and then finally 0.15 off the ends. So what percent of the shipment has heights greater than 5.32? Here is 5.32, and we're going this way. So we add up 13.5 plus the 2.35 plus the 0.15, and we're left with 16. Okay, so 16%. Next question, less than 4.96. Here's 4.96, so we're going that way. So you just have the 2. The 2.35 and the 0.15. And you're at 2.5%. Between 4.96 and 5.32, so we're going from here all the way to 5.32, which is here. And we're looking for the values between. So we get 13.5 plus 34 plus 34 is 81.5. And then lastly, between 4.84, so we have 4.84 is down here at the bottom, and 5.32, which is right here. We're looking between them. So again, I just add the values between 2.35 plus 13.5 plus 34 plus 34, which is 83.85%. Okay, so again, adding in your values in the inside and then adding up what you have. All right, last question. The mean life expectancy of elephants in a certain protected wilderness area, mean life expectancy, so that's your mu, is going to be 66 years, with the standard deviation, which is sigma, of 4.5. In a herd of 255 elephants, how many are expected to live longer than 75 years? Now, in your equation that we have z is equal to x minus mu divided by sigma. You have to figure out what your z value is based on x minus mu divided by sigma. The trick here is that you don't know what x is, right? We don't know what x is. Is it 255 or is it 75? Well, since mu is in years, then x has to be in years. You can't change it to different types of data. It's all got to stay the same type of data. So that means my 75 is actually equal to my x. Another thing is it says live longer. So that means we're going to be looking to the right of the mean. Okay, to the right of the mean. And that means that our z value on our z chart, we're going to have to look, we're going to have to subtract it from 1. Because on your z charts, it always gives you the area to the left. We need the area to the right. So to find out that area, you just subtract your probability from 1, from 100%. Okay, so first thing we need to do is figure out what our z value is. So we have z equals 75 minus 66 divided by 4.5. So 75 minus 66 divided by 4.5 is equal to 2. Our z value is 2, which means we look on the positive z chart at 2.0, which is 0.9772. My probability equals 0.9772, but that's to the left, right? That's to the left. So to the right, we need to take 1, or 100%, subtract off my 0.9772, 1 minus 0.9772, leaves me with 0.0228. That means that 2.28% is what lies to the right, but we want to know how many. So how many, how do we figure that out? Well, we take our 2.28%, right, which is equal to 0.0228, and we take 2.28% of the amount of elephants that we have, which is 255, to see how many we're left with. About 5.8 elephants. You can't have 0.8 of an elephant, so let's just say 5, because we have 5 complete elephants. or 6 if you round it up. Okay. So 5 or 6 elephants will live longer than 75 years. Makes sense because you have a mean of 66 years, which is the average. 75 is a lot more, so it's going to be quite a bit less, quite a few more or less. All right, so that's section 5 completed. There you go.